Recording is started. Starting the stream. I'll describe it. Hopefully. All right, yeah, let's get started. So, thanks for coming, everybody. I'm Ben. This is Aaron. He's the other co-founder of this meetup here. So, the purpose of this meetup is basically just to talk about like systems programming related topics and just sort of get people together in town who are, somewhat interested in this or do this as a day job or want to do this as a day job. And yeah, we really encourage people to like dig into something new. I think this is like you kind of challenge yourself to like learn some new techniques for this. And like, that's really, really great. Like I want to see people like dig into something new and explain it to people, because a big kind of mission of this meetup is to make some of this stuff more approachable. But yeah, today we have Austin. He's going to be talking about reverse engineering Sega ROMs with Ghidra. So Ghidra is, I think, is like a NSA open source thing, right?
That's
so
right. Yeah,
probably exactly what they had in mind when they wrote this.
Right.
They were just like, oh man, I really just want to know what's in this Sega ROM.
Zero tax dollars at work. So.
No, really good use of it, in my opinion.
Yeah.
But yeah, so this should be really interesting. Is there anything you want to say before we start?
No, that sounds good. Yeah.
Okay, let's get started.
Cool. Thanks, y'all. Thanks for coming, man. All right, let's kick it off. So, yeah, the word niche comes to mind, right? We're talking about, are you gonna put Sega Genesis on your LinkedIn skills? I don't know,
Definitely.
but so why put pretty considerable effort into this? Well, obviously, first because it's kind of nostalgic. I'm looking at a game that I guess was a fun experience from my childhood. It was created like a little bit before I was born, and it's interesting to see how things have changed with how people programmed back in 1991. Yeah, probably some more handwritten assembly. There was not a lot of RAM. We'll get into some of how the hardware worked and all that, but just doing it for fun. Sometimes you need a little more of a motivator than that, so to get through the hard parts. So here's a few for you. This tool is exactly designed for analyzing malware, things like that. Anything where you don't have access to source code. Obviously, with a virus, they're not going to tell you how it works, so you have to kind of pick it apart. And this is a tool that you could use for that. Some companies have bug bounty programs where, imagine like a big online bank, they would rather pay you like tens of thousands of dollars to quietly tell them about an important security issue instead of someone like stealing a bunch of money. So some people make a living doing that. And also interfacing with closed source software. So for example, there's this guy, Jakub Konka, who works for the Zig programming language and compiler. And they wanted to target the ARM Macs, but Apple hadn't released like the information on how those executables work yet. So he had to kind of like pick it apart himself so they could actually target that. And, as far as things I got better at, definitely GDB scripting, which is the GNU debugger that comes with most Linux installations and all that. So yeah, definitely learned some things, even though it's a really niche subject at its surface. So, also this is like admittedly psychological, but after staring at a bunch of assembly code and trying to figure out how it works now, if I'm like using an open source tool and I can't find something in the documentation, it's kind of less scary to be like, well, it can't be that bad, right? I could actually look at real code and maybe find what I'm trying to figure out. So the main tool we're using is Ghidra. Like you said, it was open sourced by the NSA in 2021, and it's for analyzing binaries and executables, anything where you don't have the source code available. And what you're trying to do is piece together information that was like lost during compilation. So for example, maybe you find that there's a function here and you don't know the name of it, but you can start to like put that information back in using Ghidra. So, and we'll see that. The emulator I'm using is MAME, which was originally just like for arcade machines, but they added support for consoles. And the main reason I'm using it is because they have a good debugger, so we can step through and have some breakpoints. Yeah, I'm on Windows, but all this is like totally free, open source, and it works on Mac, Linux, and Windows. So yeah. So to start out, let's just talk about some just the basics of software reverse engineering. Nothing Sega specific. So, first let's just talk about how programming works, where you sit down at your computer, you open your code editor, green symbols start like flying around, and then you're kind of like Cypher here, and you're like, yeah, blonde, brunette, redhead. So yeah, maybe someone who's not familiar at all might think like, oh, it's like something about ones and zeros, computer language, right? So you have to like speak their language, but as programmers, we know that it's like programming languages are really meant to be human readable, and eventually they interface at that level. So on the other hand, once something is like an executable, it really is just ones and zeros, right? So we're going to look at just some ways that you could interpret those. So here is just 32 binary digits. That's pretty hard to look at. So we're going to write it in hexadecimal, which this is the exact same information, just written differently. And hex, y'all can see my mouse, right?
Yeah.
Cool. Hex is nice because basically there's 4 binary digits for each character, and it just lines up nicely with how we have bytes are 8 bits. So it's better than using decimal. So, and just to start out, well, maybe it's just one number, So I'm just have some C code. I'm assuming an integer is 32 bits. And this is like what it would be in decimal. I kind of wish I didn't have to, but I have to warn about Indianness, which is, if you're not familiar, it's like most modern architectures will actually store these in reverse order, store the bytes in reverse order in memory, which sounds really weird, but it is pretty, can be useful. But I'm going to kind of gloss over it because it's less intuitive, and also the Sega uses big Indian as well, so we can just ignore that. Next, well, what if it's actually 2 numbers, right? So here I have the exact same digits up here, but I've kind of just split it down the middle, right? The 0x doesn't mean have any significance except to tell you it's hex. So here, this is an array of like 2 shorts or 2 16-bit numbers. So still 32 bits, right? Maybe it's 4 8-bit numbers. So again, same digits. And then, to complicate things further, well, hex CA here, this is hex CA as well, but it could be -54. So that's the type of thing you have to figure out while you're reversing is like, oh, is this only 0 to positive, or could it be have negative numbers? And that's going to affect how you interpret these bits. So also, why not mix and match data types? So here I have a struct. I have like 2 8-bit numbers and 1 16-bit. Another warning, which is that depending on what order you put these in, sometimes there's going to be like empty space inserted by like a C compiler for efficiency reasons. But yeah. So, and then this one is kind of interesting, right? So what if it wasn't data all along? It was actually code. So like, like the actual assembly instruction in the end is also just going to be ones and zeros. So this is the add pack double precision floating point values, which is somewhat of an obscure x86 instruction. I just had to find one that was 4 bytes long. So this is adding this register into this register. And I'll go ahead and just to prove it, I have this basically the shortest assembly file ever, which is just one line. It's not really a program, right? But I'm still gonna run it through the assembler, and it will spit out this file, and I'll show you a hex dump of it. And here 66058CA. So that's the same numbers we've been looking at this whole time. Also, what about text? So here we have a file. I mean, that's kind of a lot of information, right? Like, how are we gonna decipher what it means? Well, what if there was like a panel here where for any byte on the left that happened to be a printable text character, it would show it on the right. So I'll add this flag in. So, oh, I think we stumbled onto something, y'all. Yeah, this is still topical. So, yeah, and this also goes to show you that any binary file, if you are like looking at a hex dump, something like string data, if it's not encrypted or anything, you can actually just kind of like visually find it. So imagine something where it's like a string that says error in the password checking function, right? You can, as a reverse engineer, you can like find that and be like, well, we're probably getting close to the password function. And there's also a utility that comes with like, it's a standard GNU utility that will basically do the same thing. A little dark, but it's gonna like, it's gonna look for like some heuristic of like, oh, as long as there's maybe like 5 characters in a row that happen to be printable, it's gonna show those to you. So yeah. All right, now we're just gonna look at what kind of information gets lost when you like compile source code into a binary. So this is just like basic FizzBuzz. It doesn't like the code doesn't really matter that much. I just wanted something with some branches and some loops. So, I mean, what's like the first thing that is going to get lost, right? Comments. Like the whole point of comments is that they like don't affect the code behavior in any way. It's like just for you to see it as a developer. So I'm going to take some things away manually here. So, okay, no comments. Also, any symbol names, right? Like it functions called main. This is like argc is the name of the argument. So what if like instead of that, it just says function1 or arg1, which is kind of what we're going to be looking at as we're reversing. We don't know what it was originally called. If statements, there's not really such a thing as like if else in assembly. It's more like go to. So here we have like, we're checking a condition and then we're going to this label. But basically the same behavior as an if or an else. And while we're at it, like we already took away symbol names. So this actually has meaning in English. We're not really gonna, well, actually, let me start by saying loops as well. Loops are just like branches that go backwards and then possibly repeat something multiple times. Like I said, no label names available to us, so it's more like line 5 or like go to line 25. And it does get worse from here. So while we're at it, like we don't really have indentation, right? So this is kind of starting to look like assembly in a way, like in a really weird way. And I think it's really funny that you can compile this and it still prints out FizzBuzz from 1 to 100. So yeah, still valid code. in C. But so that's just an example of like the types of things that don't make it into the binary from your source code. And that's our job as reverse engineers, is to like figure that information out and start putting names to things that as we decipher it. So yeah, let's start the Sega portion. Has anyone played this game before? Yeah, me too. We're not looking at that. So this is a yeah. Has anyone actually heard or even heard of this game? Oh, I wasn't expecting to find it. I don't know. It was That's a good question.
Why not a Dreamcast?
Yeah, well, Sega was like I said, it was the end of an era. Like Dreamcast is like where I guess they're starting to get. I never played Dreamcast, but it was 3D, right? So yeah, like with Sega, there probably still was a good amount of like handwritten assembly. It was more limited, so, and I just like grew up playing this game. So anyway, this is a port of a DOS RPG by Strategic Simulations using like advanced Dungeons and Dragons rule set, sci-fi game. So yeah, 8 megabytes, got battery backup, which means they had a little battery in the cartridge to keep your save data alive. Like most games, you can really save. And I have a story about this seal of quality later. So yeah. As far as the hardware, this is the instruction set architecture they're using in the Sega, the Motorola 68000. So also known as M68K. It's not really used on personal computers anymore. I think it still exists in like little embedded microcontrollers, but it's big Indian, like I mentioned earlier. Registers are 32 bits. These are the names of them. And 7.6 megahertz clock rate. So that means it takes like 5 minutes for it to run what this computer can do in 1 second on one core. So Moore's law was definitely still more in effect then, but and 64K of RAM, so not a whole lot, right? So let's see. To start out, I'm gonna fire. Oh yeah. Well, actually, we're not gonna. This is just to run the emulator, but what did I do? I called it no debug MAME. I'm not brave enough for that. Got the CRT filter on, which is like the poor man's anti-aliasing from back in the day, where like you couldn't see how blocky the graphics were. It's kind of fuzzy. All right, we're just gonna watch this and appreciate it. This is gaming the year Nirvana released Nevermind. You are trying to protect Earth from the Russo-American mercantile. So Russia and America teamed up to try and destroy Earth with the orbital platform on Mercury. So yeah. Now you have all the context. So and the music has a special place in my heart. Most people agree that it's like really not very good. So, I'm just loading the team that comes with the game, so you don't have to watch me do a bunch of dice rolls and all that. We're gonna start our game. Hello, This was originally what I wanted to do the talk about, was like how to get this text in the game, but it just became way too complicated. It would have been a talk about compression, which I only really just started learning about. So, LCW, which is like the same. I think they have PDFs and shit. So, Yeah. It's not just like giant textures. You can't have like a text file. Yeah, a little too much data. So your mission is to figure out where enemy health is stored in the RAM. Let's take and I have to fast forward a little bit. All right, and then the really important cutscene. Yeah. No, we get a shot at. Just taking a nap here. Okay. Yeah, basically. Yeah. So sometimes, you walk around, you're like, wow, I get to fight every 2 seconds. Sometimes it takes this long. So there are. Wow, that's never taken quite that long, but okay. So we're getting in a fight right now, and so first, what I'm gonna do is like save a state here. So, and then I'm gonna quit and reopen it in the debugger. I needed to have that full screen experience for the immersion, but so. All right, now we've loaded our state. Again, we're trying to figure out where the enemy's health data is. So first of all, let me, I'm just gonna attack and see if we hit or not. Okay, good. So luckily the way the game's random number generator works is it's kind of like predetermined in this save state. Like we know we're gonna hit this guy now. So what I'm gonna do is attack and then hit a breakpoint basically, and I am going to advance a frame at a time until that laser's almost hit him. So now our strategy is we're going to save the entire state of the RAM right before and right after the laser hits. And like we're trying to minimize what's changing. Like there's stuff moving on the screen and stuff like that. Like that's going to give us all these false positives that we have to sort through. So hopefully we're going to find just the health that goes down. But so first of all, I'm going to save this and call it pre-hit. I'm saving it from this address. That's just where the RAM always is on the Sega. It's kind of like embedded programming. And to figure that out, you just like look it up. There's all these manuals. And now we're going to wait for that laser to hit. And we're going to call this post hit. And okay. Next, I'm going to open this hex editor. It's another free tool. The first time I did this, I just was using like standard command line utilities like diff to figure out this, So just so you know, like you don't have to have a bunch of fancy tools or whatever, but this is a nicer way to do it. Oh, this is the folder for when all that doesn't work. And I have to pull up a video of it. We're not out of the woods yet, actually, but so this is like a cool feature that this hex editor has. First of all, let me also just show you something. And hopefully we will find some. There we go. So remember what I said about like the text is kind of just sitting there for you to read, right? It's like, I know it's really tiny. Right? This is, I can't, it's the way this program works and I'll get through it, but it's going to be pretty brief. Anyway, here we just like on the left, we have a bunch of bytes in their number representation. And on the right, like, oh, there's actually, readable strings there. So, okay. So what we're going to do is we have this like diff tool. I have the RAM from before the laser hit and then the RAM state from after the laser hit. And it's going to show us any place where something differed. So here we have a byte that went from hex 82 and it went up to hex 9C. So something went up, maybe, probably not it, right? So let's see what we have next. Well, here's something that went from hex 10 down to hex C, which is 16 down to 12. I always have to think about it. It might be 13, yeah. But so it went down a little bit. And here it's telling us the address, like what exact location it was that the value went down. That might be the enemy's health. So C568. So what I'm gonna do now is y'all help me remember that number. No, it's gonna be there. So so I'm gonna set a watch point, and I'm sorry about the font again. Like same thing here. I can't really make it bigger, but what I'm doing is in the emulator's debugger, I'm gonna set something that'll like pause execution when anything modifies this spot that I'm looking at. So what I want is to figure out what code is lowering this guy's health. So C568, I think. And it's okay. So let's see what happens. So that's a really good sign, right? Like it paused right when the laser hit. So like I think we're onto something. And here you can see the actual assembly instructions that are running, and I can see, oh, this is the exact instruction that just subtracted something from something. So probably the enemy's health. So I'm gonna set a breakpoint there at 7622, and first I'm gonna load state, and then I'm gonna do that. Okay. So we're about to subtract the damage from probably the health, right? So what I'm gonna do is change the value in this register to something really high. Let's like see what happens, right? Maybe we'll deal a whole bunch of damage. We hit him with a refreshing healing laser just now. So like, what happened? His health just went really high. So probably we skipped a step, right? Like we kind of were right in the middle. Like maybe there was something that was going to check if we had enough to kill the guy. But instead of doing that, it subtracted below 0, and then it like went up to some really high number.
I like it better this way. It's much more positive.
Yeah. Yeah, it's a little too violent. So, that's not meant to be like, oh, like memorize these steps and like this is how you could reverse the Sega ROM. I'm just trying to say like this is how you could kind of like decipher like what's happening, and these are some steps. Let's take a before and after snapshot. What changed? There's a lot of guesswork involved. I've already done this before, so I'm gonna be kind of like breezing through it. I'm not an assembly wizard, but I'm just showing you like how is this even possible, because that's like what I always wondered before I got into this stuff. So now we actually know the instruction that subtracted the enemy's health. So I'm gonna go ahead and open up Ghidra finally, which is our binary analysis tool. I'm gonna import our Sega ROM, and we're gonna see an awesome. Well, you'll see in a sec, but it detected that it was a Sega ROM somehow, right? Like how did it even know that? Well, that's because I downloaded a user-made plugin that can knows how to load those ROMs. So Ghidra is highly customizable in that way. And then how did it know that it was a Sega ROM? Well, it probably looked in this one location where I'd always literally says Sega, which was like some source of a lawsuit about copy protection because Accolade released a game that said Sega there, and there was a whole thing. But so now we're going to go ahead and import that. It's asking me about some optional stuff that we're not using, and I'm streaming, so okay. Hopefully nothing goes wrong here, but And now I'm going to open it up in the code browser. And it has not been analyzed. Would you like to analyze it? So right now it's just a big pile of numbers, basically. And what this is going to do, I'm going to use all the defaults, which is like, oh, I'm going to look for any functions. I'm going to look for strings, things like that. And let me get out of the decompiler view and into the listing view. It had some stuff set up for it. The loader had some helpful things like it already named this function reset. Well, that's the code that executes when you hit the reset button. So like, there's some things already figured out for us. As far as this stuff at the top, this is like a list of functions that run on certain error conditions. Like here's one that says divide by 0, right? So remember I mentioned that Sega seal of approval? In order to get that, the game had to go through this series of tests, one of which was like, can you start a level and then just leave it running for a week? And is it going to crash or not? Like imagine there's a timer running that keeps going up and then it wraps around to 0 and something divides by 0 and the game crashes, right? So normally this code would be like print error divide by 0 to the screen. But the people who made Sonic 3D Blast, instead they had it say, congratulations, you found the secret level select menu. So that was like their approach to getting the Sega seal of approval. They're like, no, it didn't crash. Like you just unlocked the secret. Whatever. So, and like, how did I figure that out? Well, like me and my brother were 7-year-olds running around and tripped on a wire. You bump the cartridge and then cartridge read error happens and it says, congratulations, you found the secret level select. And then you go on Game FAQs and they say, I swear I'm not making this up. You just have to tap the cartridge a little bit and that's how you get there. So yeah, that's that. Now earlier we saw which instruction lowered the enemy's health. So I'm just going to jump over there, which is 7622. We are looking at a bunch of disassembly, which, like I said, unfortunately, there's no real names. There's all we know, like here, it's just this function at 7608. We have no idea what it does. We just know where it is, and we know it's a function. So our job is going to be to like piece some of this back together. So, and while we're at it, like I'll go ahead and call this maybe deal damage because sometimes it's good to have that maybe. Sometimes you're not sure about it, but you will be scrolling around and you'll see that name pop up again and you will say, oh, I've been there before.
So that replaces all the like call signs.
Anywhere else. Yeah, exactly. So, yeah, and then I'm just going to kind of breeze through this because I don't want to bore everyone with a bunch of assembly code. I'm just going to show some of the features of Ghidra. So here's one, like we come in right away. We're assuming that there's this register that already has a meaningful value. Well, that's probably an argument that was passed to it. So, and if I look ahead, I can see that it's being subtracted from what's presumably the health. So I'm basically making a function signature here. And I have to tell it where it is stored. It's in a register. It's in D0W. And now, eventually, by the end, this is going to like start to look kind of like C code or whatever. So a little bit. Next, we're like looking at the value stored by a certain pointer and possibly branching to another label. That's like the go-to I was talking about earlier. No if statements, just go-to. Well, this one is at the end of the function right before we return, so I'm just going to name that one. Instead of label blah, 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 a bunch of hex digits, I'm going to call it end. And if I go back, like we were talking about, everywhere it shows up, now it has like a meaningful name. So we're starting to, put some meaning onto this pile of numbers. A3 has a meaningful value. Like I said, I'm just going to breeze through this. I've already done this enough times and don't want to bore people, but I'm like adding another function. This is a pointer to the person that we are shooting right now. So, and it's in register A3. And finally, remember how I was talking about how we lost our indentation and we were really sad. We have this really nice function graph view, which basically takes a bunch of blocks of instructions and it can tell that like, oh, this is kind of like an if statement, right? This is a go to here. Otherwise, we're going to do this code. Well, it can actually add some indentation for us. So that's like really helpful. And we can also see if something's looping. We're starting to get our control flow back. So, and yeah, basically what we're doing here is like checking whether it was enough to, whether this register, whether the damage was enough to kill the guy, and then it's gonna kick off a series of events if so. So, and then the last thing I'll show is that we have like this decompiler view. So what this is actually doing is like looking at all that and it's trying to spit out equivalent C code that would have the same behavior as that assembly. So yeah, this is actually like, it's still not nice to look at right now. There's a bunch of really crazy typecasting happening and it's trying to like appease the C type rules and don't always work well with the actual instructions. But what you can do is like, you can start to give types to these and I can say, name things. I can say, oh, this is damage and this is the target health and all that. And I can even figure out that something is like, oh, this is actually a struct and it's going to figure things out for me. Instead of being a bunch of crazy typecasting, I can say, this is the target status, whether it's alive or dead. This is the target's health. Like, okay, now it's starting to look like code. And then, you know, just to finish, I'm going to back out and show one that I already marked up a little bit. And like I said, still not the prettiest thing, but you know, we have like some named variables. I actually have like a data type that knows what's in the thing we're attacking. It knows that there's like, oh, the health field is exactly here. And I have like, instead of saying status equals 2, I have it saying status equals unconscious or like dead because that's what it is in the game. So like I said, what we're doing is like trying to put meaning back into something that got stripped of all its names and comments and put that back together. And you know, I didn't really mean to rush through this last part too much, but I'm like I said, I'm not an assembly wizard. Like I've just like done this a bunch of times already on this exact function. I just wanted to show what it might look like as you start to piece these things back together. And yeah, it's a really useful tool for that. So
when you're choosing like email names and stuff, I mean, is that just from trial and error of like playing the game and then the person is like unconscious?
Well, I noticed that it's like what it's doing is it's saying, oh, like if you do deal enough damage to kill this guy, it's gonna calculate like how much surplus like damage did you have, and it's like, oh, if you had, it was just enough to do it, then you're gonna do this, and it's like, well,
so
if
you're
it
using
was,
context from the code around
yeah, and that does bring up a good point that you can't always like run the code in a debugger and like step through like, especially if you're dealing with malware or something. I'm sure there's ways to like sandbox it. Like maybe you're in a virtual machine and it's okay to actually run the virus, but like you don't always have the opportunity to do that. And they call it static versus dynamic analysis. Like Ghidra is more about the static analysis. We're just, you know, looking at some non-running code. Although Ghidra does have a really cool feature where it can actually emulate some of the instructions. Obviously, it can't emulate how a Sega controller works or something, but it will run through a function and you can kind of like, in a safe sandboxed way, you can run something. And yeah.
But you could also play the game and you could say, okay, I've kind of figured out there are sort of 4 different states here, and that's what they sort of are.
I definitely had to get it that way. Yeah, maybe after like a ton of staring at it and finding the strings, like you could find it or whatever. But you know, yeah. So just a taste of like how this type of thing is even possible. It's not magic. Sometimes it does take a lot of patience. I mean, can be fun, like solving a puzzle, kind of. But yeah, I guess in closing, Ben said there didn't have to be a moral of the story or anything, but I'll just say sometimes you have to work on a really random project that seems to have no purpose, and then a couple of years later, you're like, I really learned something. It got better.
Yeah, totally.
Awesome.
Thank you.
Yeah, we're still streaming. Yeah, thank you again. That was awesome. I was really had a lot of fun. I can't wait to get home and try and decompile my own SNES games now.
Oh, yeah.
But yeah, if anyone else has any talks they want to do, come talk to me or Aaron, and we'll give you ideas as well. I think like you kind of Lucy had this idea, I pushed you into a little bit, but yeah, it turned out awesome.
Oh
So
yeah,
thank you.
no, I'm glad. It's nice to have a deadline sometimes.
Yeah, and like these kind of things, like we're kind of joking about how it's like, there's no point to it, but like really, I mean, this is how you like learn interesting things. I think like doing things for fun and doing things just because they're challenging, like is how you grow. So I think like this kind of thing, these skills and these tools that you learn, like I'm sure you could show this to someone at NSA and they'll be like, yeah, you want to come to work for us? Like you know how to use our tools, right?
Trying to figure out this
it's a serious
cheat
thing.
code.
Like,
Yeah.
It's, this is not too dissimilar from what they do on a day-to-day basis.
Right.
You just got good at the game on
Although they may have a Buck Rogers division that's just playing Buck
Yeah.
Rogers. It's possible.
Right.
But yeah, reach out. But anyway, thank you. Thanks again. And we usually go to Rusty Nail, but it's closed. So we're going to figure out where to go. If anyone wants to hang out, maybe courtyard or something, we'll discuss on the way out. But
Awesome.
thanks again, everyone.
Thanks.
Yeah.
Oh,